Jupiter is the largest planet in our solar system, a world so massive that it contains more than twice the material of all other planets combined. When we look at Jupiter, we are seeing a planet that preserves the early history of the solar system, a world that never became a star but grew large enough to shape the orbits, composition, and evolution of everything around it. Before we dive deeper, take a look at this side-by-side image. One of these swirling patterns is Jupiter. The other is Earth. At first glance, they look almost identical. Spiraling currents shaped by turbulence and rotation. But one is a storm in Jupiter's atmosphere, and the other is a phytoplankton bloom swirling in the Baltic Sea. Two worlds driven by the same physics, yet utterly different in scale and nature. Jupiter formed early, within the first few million years of the solar system's birth. In the swirling disk of gas and dust around the young sun, it accumulated more and more hydrogen and helium, the same elements that make up stars. Had Jupiter been about 70 times more massive, nuclear fusion could have ignited in its core, and our solar system might have been a binary star system. Instead, Jupiter became a giant planet, a failed star in mass, but an essential stabilizer of our planetary neighborhood. Jupiter's appearance is instantly recognizable. Its atmosphere is a vast world of hydrogen, helium, swirling storms, and colorful cloud bands. These clouds form in layers, with ammonia ice at the top, deeper water clouds farther down, and complex chemical compounds that create Jupiter's reddish and brown hues. The planet's rapid rotation, just under 10 hours, stretches storms into long, bright and dark bands that wrap around the globe. Within these bands, jet streams blow at hundreds of kilometers per hour. One of Jupiter's most famous features is the Great Red Spot, a colossal storm larger than Earth. It has been raging for at least 350 years, possibly much longer. Though it has changed in size over time, the storm remains a powerful symbol of Jupiter's energetic atmosphere. Lightning, auroras, and deep storm systems hint at a world far more dynamic than pale clouds suggest. Beneath the clouds, Jupiter transitions into deeper and hotter layers of gas. Pressure increases so dramatically that hydrogen transforms into a strange state known as metallic hydrogen, a fluid that can conduct electricity. This layer, combined with Jupiter's rapid rotation, generates the most powerful magnetic field of any planet, extending millions of kilometers into space. Jupiter's magnetosphere traps radiation and shapes the environment around its moons, creating conditions both dangerous and scientifically valuable. Orbiting within this magnetic environment are Jupiter's 4 major moons, the Galilean Moons. These worlds are so large and unique that each could be a planet on its own. Together, they form a miniature solar system, offering some of the most fascinating and important destinations in space exploration. The most intriguing of them is Europa. Slightly smaller than Earth's moon, Europa hides a global ocean beneath a shell of bright, icy crust. The surface shows cracks, ridges, and regions of smooth ice, where water from below has frozen, creating a patchwork of lines and patterns. Tidal forces from Jupiter flex Europa's interior, generating enough heat to keep its subsurface ocean liquid. This ocean may contain more water than all of Earth's oceans combined. Because it is in contact with a rocky seafloor, Europa is one of the best places in the solar system to search for life. Future missions, including NASA's Europa Clipper, will study its surface, measure its ice shell, and search for evidence of plumes that could reveal the ocean's chemistry. Another remarkable moon is Io, the most volcanically active world in the solar system. Its surface is constantly reshaped by hundreds of erupting volcanoes, fueled by intense tidal heating caused by Jupiter's gravity. Lava lakes, mountains higher than Everest, and vast plains of sulfur give Io a landscape unlike any other world. While Io's environment is too extreme for life as we know it, its constant geological activity helps scientists understand tidal forces and planetary heating. Ganymede is the largest moon in the solar system, even bigger than Mercury. It has its own magnetic field, the only moon known to possess one. Ganymede's surface is a mix of ancient craters and younger grooved terrain created by tectonic forces. Like Europa, Ganymede likely hides a deep subsurface ocean, though buried under much thicker ice. Its complexity makes it a key target for exploration, especially for ESA's JUICE mission, which will study Ganymede in detail. The fourth major moon, Callisto, is a heavily cratered world that has changed little over billions of years. It preserves the solar system's early history on its surface, a geological time capsule. Callisto may also hold a subsurface ocean, though likely colder and more isolated than Europa's or Ganymede's. Its stable environment and lower radiation exposure make Callisto a potential future site for human outposts around Jupiter. Beyond the Galilean Moons, Jupiter is home to dozens of smaller, irregular moons, many of them captured asteroids or fragments from ancient collisions. But Jupiter's gravitational reach extends even farther. Along its orbit are two vast swarms of Trojan asteroids, frozen leftovers from the early solar system. These Trojans have remained trapped in Jupiter's orbit for billions of years, acting like time capsules from the era when the planets first formed. NASA's Lucy mission is now on its way to visit several of these Trojans for the first time. By studying them up close, Lucy will help reveal what the solar system was made of before planets like Earth even existed, and how Jupiter's gravity shaped that early chaos. Jupiter's immense gravity also guides comets, influences asteroid families, and helps protect the inner solar system by absorbing or redirecting incoming objects. Exploration of Jupiter has revealed a world of endless complexity. NASA's Galileo spacecraft orbited Jupiter in the 1990s and provided the first close-up studies of its moon's atmosphere and magnetic field. Today, NASA's Juno mission is delivering unprecedented insights, from measuring Jupiter's interior to imaging its poles and storms. Future missions from NASA and ESA will continue this exploration, focusing especially on Europa and Ganymede. Jupiter matters not only because of its size, but because of its influence. Without Jupiter, the solar system would be a different place, perhaps more chaotic, perhaps less protected, and possibly without Earth as we know it. By studying Jupiter, we learn how planets form, how solar systems evolve, and how life might emerge elsewhere. Jupiter is not just a planet, it is a giant archive of the early solar system, a world of extreme storms and hidden oceans, and a reminder that even in the familiar space around our sun, there are still mysteries waiting to be explored. Thanks for watching. If you enjoyed the video, consider subscribing for more space stories every week.